Janelle is planning to rent a car while on vacation. We got this equation that models the relationship between the cost per day and the number of miles driven. So the more miles, obviously the more cost. We're supposed to find the cost if Janelle drives the car 0 miles in 1 day. 0 miles in 1 day. So 0.32 times 0 plus 15. 0 goes in for miles. And if you simplify that, 0.32 times 0 is 0, so this is 0 plus 15, so the cost is $15. Part B, the cost for 400 miles. We need to find out what C equals when M is 400. So we've got 0.32 times 400 plus 15, that makes 143. And we need to interpret the slope and C-intercept of the equation. So the slope is the number that's attached to your independent variable. It's usually attached to x, but m is our x in this example. So the slope is 0.32. A slope tells you how much the y variable changes based on one increase in x. So the interpretation for the slope here would be for every mile driven, there is an increase of 32 cents in cost. That's the slope. And then the y-intercept, the cost is $15 if there are no miles driven. So m equals 0. That's your y-intercept. What happens when your x variable is 0? 0. So $15 when m equals 0. That's our y-intercept. And then to graph the equation, this is kind of tough to do. You can just make a quick sketch. Okay, here's 15 on the y-axis. Put a dot there because at 0 miles, 15 for cost. And then 0.32 for one increase in miles. Maybe we could make 400 over here. No, that's too much. You could just try to find another data value. Like if you plug in m equals 10, if you plug that in, then you get c equals 18.2. So at 10, we're up to a little above 18. That's enough information to have the graph. Okay, so just a quick sketch there.